So thank you everyone for joining. Tonight we have 5 alums, 4 of those who work at Lockheed and 1 who works at MITRE. So I'm going to have each of them introduce themselves real quick and then we will go through their presentations. So Sean, do you want to introduce yourself first?
Sure. My name is Sean Tibbetts. I'm a recent grad from the University of Alabama. I would hope that you guys know that. Most of you might know me from my time as the propulsion lead for either Deimos or Ares the last 2 years. I currently work for MITRE now, doing ballistic missile defense analysis and other fun stuff.
Awesome. Thanks, Sean. All right. I'm just going to go in the order that you guys appear on my screen. So Jacob.
My name is Jacob Montgomery. I am also recent grad. I work at Lockheed. Well, I started at Lockheed ARA and transferred to Lockheed Sikorsky. I'm both doing mass properties work.
All right, Zach.
Hey, my name's Zachary Comose. I'm also a recent grad, aerospace engineering with minor in mechanical, and I'm a project engineer associate for Lockheed Martin Space on the THAAD new business team.
All right, Logan.
Hey everybody, my name is Logan Cummings. In case you didn't guess, I am also a recent graduate. Currently working as a systems engineer at Lockheed Martin Space on the Terminal High Altitude Area Defense Program.
And Claire.
Hey y'all, I'm a recent grad as well. I work Lockheed Space as a thermal engineer in deep space exploration.
All right, thanks guys. So I will probably just go in the same order and have you guys just present your presentations. And then after that, there will be time for questions. So hopefully you guys, audience members, are thinking of questions. If not, I will ask some, but I'd rather them come from you guys. So yeah, we'll go ahead and start with Sean. Sean, do you want to share your screen or have me pull it up?
I would like to share my screen.
All right, well, I will enable that really quick.
That was probably a smart move.
All right, got it. Go right ahead.
Okay. Let's see.
Oh, this is exciting.
All right, which one's up? I don't know which.
It's the presenter view is up. So the one you had first was the one you need.
There we go. Still the same thing, of course.
Yep. No, you're good.
I'm all set.
Yep, you're set.
Thanks. Okay, so MITRE. Most of you probably have not heard of this. I didn't hear of it until about my junior year when I was talking to one of my friends, Peyton. But tonight, I'm hoping that you're going to learn a little bit more about what MITRE does and what I do there. So, first up, a brief history of myself. I was a member of ARA for the last 4 years. I was on Deimos and Ares as propulsion leads. I, of course, led Sean's Minions, if any of you remember that. I grew up in Central Florida, so I used to watch a lot of rocket launches, like a lot of them. I'm a huge rocket engine nerd, and I've actually built 3 CubeSats that launched on that Falcon 9 that's showing on the right side of this screen here. I graduated from UA with a bachelor's in aerospace, and I currently work for MITRE. So what is MITRE? Well, first of all, MITRE is what we call an FFRDC, which is a really long acronym that stands for Federally Funded Research and Development Center. Basically, this means that we do work without getting contracts assigned to us, or the government tells us, hey, do this analysis, and we go, yep. But MITRE's not just like a one-trick pony kind of thing. We have a lot to offer. So we have specialties, in defense, aviation, homeland security, healthcare, and cybersecurity. And then there's also like 2 or 3 more that MITRE does. When I first came on, I had to ask this question throughout the entire first week, like, what does MITRE actually do? Because I only had a very small picture. And my picture is actually the second part. It's called the TDA. I work for the Missile Defense Agency on a team called the Technical Direction Authority. And basically what this means is that when the government has to pick a new type of missile to buy or field or test, they go to MITRE and they say, out of all these contractors, which one is the one that we should buy? Because if you ask a Lockheed guy, he's going to say Lockheed. Now, this means
I mean,
that
it's the right answer.
sometimes it's the right answer. It can also be the most expensive answer. This means that we support new acquisitions, fielded weapons like THAAD, this picture up right here, and we actually work to solve a lot of the hard problems that pop up after these things get sent out. Lastly, go ask your mother. As an FFRDC, MITRE actually runs 7 other FFRDCs. And what this means is that when the government asks for something really weird like seismic analysis, instead of drawing up a contract and hiring a guy and going through all the steps and processes to go, 2 years later and get an answer, we go to Albuquerque Seismological Laboratories out in New Mexico and we say, hey, government, ask these guys. They know exactly what they're doing. So there's like very little dawdling with getting all of these really quick answers for the government. So why do we want to use FFRDCs? And I kind of hinted to this with the whole Lockheed thing. If you ask a Lockheed guy what missile the government should buy, he's going to say Lockheed. So if you have companies like Raytheon, Aerojet, Lockheed Martin, can't believe I almost forgot that one, Boeing, and then maybe some other smaller ones, which one should the government pick? Well, thankfully, the government doesn't have to answer that question, or else we'd still be using those nuclear tipped Nikes from the 1960s. This means that you have to have somebody that's nonpartisan. You go through, you double check everyone's math. You make sure you have communication between a Raytheon guy in the government or a Lockheed guy in the government. And you also have to make sure that all those requirements that the government comes up with are realistic and feasible. Because if you go to THAAD and you say, hey, we want to put something into low Earth orbit, they're going to say no. Lastly, subject matter experts. MITRE is full of subject matter experts. Everything from hypersonic development, aerodynamics, to radar systems, even linguistics. It's a super diverse environment, which means that if you want to get super nitpicky with your questioning, FFRDCs are the right place to go to. So what do I do? Well, I'm a ballistic missile defense analyst. And that means that I have to go through and actually review all these contractor designs. Now, living with 2 other Lockheed roommates, it means that I really can't talk about my day at the end of it. But we go through designs, trajectories, and ultimately kind of come up with a list of capabilities. We compare each design against each other and figure out which one is the best for the US government, which one is the best to keep families safe and the entirety of the California coast, in one piece. We also have to look for weak points in US defenses. We look at a lot of new ideas. We have a whole program devoted to just coming up with new ideas and looking at research topics. Because a lot of the time, there's something new that comes up while you're developing a tool or while you're tweaking someone else's design, and that can go into a whole nother rabbit hole. Lastly, we just look to provide meaningful support to a vast majority of these systems. I support the GM, which is the ground-based mid-course defense. So this is the big GBI, the ground-based interceptor out in California, Vandenberg Air Force Base and Fort Greely. And its job is to intercept a missile when it's still kind of in that coast phase, when it's flying in a free flight type orbiting path. Because you don't always want to have to use THAAD every single time. If it comes to the very end and THAAD misses, which it might not, then you're kind of out of luck there. So lastly, I just wanted to talk about why I really love MITRE. There is a huge opportunity for me to just move around and explore any missile defense system. Currently, like I said, I work on the ground-based interceptor, but there's also a lot of talk about hypersonics going on. I don't have to worry about changing divisions or looking for a new job opportunity within MITRE. I can just talk to my boss and say, hey, I'm really interested in this, and they'll find somebody to help me out with that. They have an amazing support program for tuition reimbursement. And in fact, one of my meetings with my boss, they really talked about how much they loved learning. My boss has 5 master's degrees and is working on his 6th right now. And 6 master's degrees means that you have to be pretty smart. And it seems like everybody at MITRE is just incredibly smart. I feel like the dumbest person in the room whenever I'm on like a Zoom call or something like that. Last thing, there aren't any contracts, which means that I don't have to worry about getting a specific contract to keep my job or moving to different contracts and kind of being out of the loop. I can just work on stuff that directly supports America's defense systems. And that's all I have.
Awesome. That was great. Thank you so much, Sean. All right. We are gonna go ahead and just save questions for the end. So next, Jacob. Do you want to share your screen, or would you like me to pull it up? You're muted.
Can you pull it up?
Yep. Alright.
Classic.
Okay. Here we go.
All right.
Wait, there we go.
So just a little intro about myself. So I was hired to Lockheed in September to Lockheed ARA to the mass properties team. And kind of what they do is a lot of weight tracking and CG tracking to make sure that the aircraft is okay and functional to fly and meets all the requirements that the Air Force or customer wants it to be. And so when I started, I was working on the F-16, F-22, and the NASA, well, Sierra Nevada Dream Chaser. And so that was really cool because I was able to work hands-on and like climb in an F-16's cockpit. And so that was really cool to start. And then I was talking to my boss about how I was from the Northeast and a position opened up and he asked me if I would want to get transferred up here or up there. So to be closer to family and stay like in mass properties. And so now I'm working at Sikorsky, which is the rotary mission systems line of business at Lockheed Martin. And so pretty much doing the same thing, the same job, just on the Naval Hawk, Black Hawk, and then I've done some stuff on the presidential helicopter and the international version of the Black Hawk. And then you can go on the next slide. So like I was saying before, I do weight and CG tracking on different modifications of the aircraft. And so I'm not sure if you guys know, but the F-16 and F-22 are the older jets or the last generation jets, where the F-35 is like the next generation fighter. And so in order to keep the F-16s and F-22s up to the technology that we have, there was a big push for the modernization on those aircraft. And so that was a lot of the stuff I was doing back when I was at Aero. And so things even just like running fiber throughout the entire aircraft to be able to support the new electronics. And so with this, it's determining the mass distribution and inertia characteristics of the different aircraft, so to make sure that the aircraft's going to fly the way the pilot's expecting, or even things like if they're performing maintenance on the jets, sometimes they will remove the engine. I need to find out what jack points they could use on the aircraft in order to lift it up and so it won't tip over, which has happened before at Lockheed multiple times. And then some of the stuff I've done is, or like something I'm working on now, is for the international version of the Black Hawk. They're thinking about putting in a new engine. And so just coming up with the predicted weight change that the install of the engine will have and how that will affect the characteristics of the aircraft, how that will affect how many people can be in there, or what they can do and stuff like that. And then one of the other things I do is I communicate with a lot of different attributes teams. So this would be like the loads team, stress, finance. And so to come up with the best cost benefit solution to different problems. And so, like for example, if there's if aluminum won't work and steel is too heavy, is it worth the money to go to something like titanium or more something that's more expensive to produce and machine? And that's pretty much what I do.
Awesome. Thank you, Jacob. All right. Next up, we have Zach. Zach, do you want to pull up your presentation, or would you like me to?
Could you pull it up? I don't think my computer would like that too much.
I can. Just give me 1 second.
Surface can't handle it.
Yeah, it's seen better days.
Don't worry, my Surface is older than yours.
I know.
I need to switch to Mac.
Ha ha ha.
Nah.
All right. Take it away.
All right, so this is my story. Up at the top, you see me standing there in a field of ducks, courtesy of Logan, and then also me holding my baby Jacob. We used to have a great Photoshop guy on ARA last year. His name was Greg. Hit him up if you want anything Photoshopped. He'll love the attention. Next slide, please. So a little bit about me. I'm from a small town called Chapin in South Carolina, and I went to UA, obviously, and graduated with a bachelor's in aerospace engineering and a minor in mechanical engineering. Currently, I'm working for Lockheed Martin as a project engineer associate. Like Jacob, I got hired last September, or September 2019, as at the Lockheed Martin days. So I highly recommend you guys to go to any events like that if you have the opportunity this year. It's a great way to get an internship or get a full-time job offer, like a lot of us got. Some of my hobbies are hunting, fishing, hiking, and building things. I also like anything space, so just the combination of just a general interest in space and liking to build things kind of drove me towards the aerospace engineering route. Up at the top center, you see a picture of me attempting to build my 3D printer. No electrical fire hazards there or anything. A couple of those wilderness pictures were from my last hiking trip to like the highest point in South Carolina. It was pretty cool. And just some generic outdoors pictures, me hunting this year and doing a nice annual fishing tournament with my family. Next slide, please. So my time in ARA, I joined a little bit later. I joined my junior year at like the club's day, and then I joined the junior team. It was the like Ares for Polaris, and on that I joined the avionics sub team. And on there I worked as mainly working with the transmission systems because it was the first year we were trying to do the live telemetry thing. So I worked with coding for the radios and designing the antenna and the antenna that would be mounted on the rocket and the ground station reception area. And so with that, I also worked a little bit with like the battery design, making sure that everything had enough power. So a little bit outside of like the generic aerospace engineering like skill set. So it was pretty cool to like widen my horizons and learn some more skills that like I previously wouldn't have gotten in just my generic aerospace classes. After that, I helped co-lead the avionics team on Ares 5 with Jacob. On there, I focused more on the electrical power systems. So up at the top center, you can see the battery that the battery bank that I designed and almost got the chance to build before we all got sent home. And with that team, we created a full system and were able to test it. So at the bottom right, you see an example of our circuit that we used. We used like a BeagleBone, and then that would compile the data from a GPS, barometric pressure sensor, and an IMU, and that data would all feed through a couple systems and go into the BeagleBone, which would then transmit it to the ground. And so on both teams, we managed to launch and recover a combined total of 2 rockets, which I'm pretty sure was a club record because we both also managed to recover all of them. And the first prototype, the prototype at the bottom left, was the first avionics bay that we constructed. And that was going to go in the Polaris 4 rocket, which you see in the top right corner. And that was about, 14 feet tall. We never got the chance to launch it, but we did utilize all of the pieces for Franken rocket. Next slide, please. So working for Lockheed Martin. Like I said, I'm a project engineer associate on the THAAD new business team. And what that means is I help construct the bids for the different contract requests that the MDA puts out. And I work specifically on the US side of things. So I help fulfill the bids for like new interceptors or the new launchers, radars, stuff like that. I don't work any of like the foreign contracts or the like advanced capabilities development, like for the developing new THAAD capabilities or anything. It's just strictly hardware and software upgrades that the United States military needs. I also maintain the different information sharing systems that the team uses to make sure everybody's up to date. That includes updating like Excel sheets with VBA code to automate all the processes and help make it easier for people not to corrupt each other's data and things like that. Because when you're working with a wide variety of people who don't always understand different newer like PowerPoint systems and Excel, they can kind of mess them up a bit. So somebody has to go in and fix all of that. And then I also create weekly meetings and lead those and help keep the directors of the program up to date on all the new things that are being done. So there's me on my first day of work. I got sent immediately home because of the COVID protocol, but they did let me out one day back on campus to see the THAAD launchers. And they had one of their test systems set up in the parking lot. It was pretty cool to see. Good to actually see what I was working on. Next slide, please. So ARA helped by giving me the experience that I needed for the full engineering design process that allowed me to talk to the recruiters. And so like at the Lockheed Martin days where I got hired, I just talked about all my experiences in ARA and like the different design problems that I solved throughout my time there, and it impressed the recruiters, and then that's how I got the job offer. It's also a great team learning experience working with the different, both my sub team and then the larger year team as a whole. It definitely helped build a lot of good skills that are very useful nowadays with the communication and information sharing that goes on at my job. It was also fun because I got to apply different skills that I learned in my classes, like structural design with composites, which we learned later on in aerospace, aerodynamics, just some basic like electrical systems that we learned freshman year, and then propulsion and flight sims. I also learned things that you are not taught in classes, which I found very useful later on, like learning how to machine the materials that when you do design something that can actually be made and it's not just sitting there on paper. I also learned new programming languages like Python, further electrical engineering design principles, data transmission with radios and antennas, along with prototype construction and troubleshooting, which is pretty important when because it's just a generic problem solving skills to learn through experience on that. And also test plan writing, which has helped me in my current job. And then let's see, one thing to mention is that the project engineering role isn't as much of a engineering role as it is like a glorified business role. So if you are looking for something more hands-on and engineering wise, then you probably want to stay away from it. But if you're looking for a good overview of a whole system and you're still able to apply your engineering knowledge because you see the system from a top-down view. So you see what components have to go into it and why you have to stay up to date on like where you're sourcing things from, then it's probably a good role for you if you like that kind of thing. And I think that's it. Thank you, guys.
All right, thank you so much, Zach. Next, we have Logan. Logan, would you like to present yours, or would you like me to?
Since you already did Zach's and Jacob's, I mean, I'll just stick with the theme.
I'm doing like a pretty good job at it, I would say.
Yeah.
The best.
Plus I've got the Surface 2, and it might not like that.
I can hear the fan going.
Can you really? Can you actually?
Yeah.
Back up a little bit. Can you still hear it?
Yes.
That's all right. It's not that bad.
Oh, well. Just gonna have to deal with it.
All right.
This show must.
So as you said, my name is Logan Cummings, and this is a little presentation about my life at Lockheed. So I want to start off with a little bit about me. I'm from Green Bay, Wisconsin. I've been a member, I was a member of ARA for 2 years. Both times I was on the avionics team. The picture on it is, you may have heard Zach mention Franken rocket. That is Franken rocket. That's our avionics team test rocket from last year, right before we all got sent home from COVID. I graduated last year with a bachelor's in aerospace engineering. I also got some really positive feedback from Sean earlier. It said I can cook a mean cold beer. Not sure what that means, but you can fill in the blanks there. And currently I'm a systems engineer working for Lockheed Martin on the THAAD missile defense program. So a little bit about Lockheed Space, which is the business unit that I work for. It's the second largest business area within Lockheed after ARA. They've got several large locations across the U.S. Our space headquarters is Denver. There's still a lot of stuff done on Sunnyvale, California, Valley Forge, Pennsylvania, and Huntsville, Alabama, where Zach, Sean, and I are all located. Then within space, there's several different business units you can get into. You can get into more of the civil space, communication satellites or space probes, the new human landing system, military space, or you can always go for missile defense like that, which is my program. And then on the next slide, a little bit about THAAD. It stands for the Terminal High Altitude Area Defense. It's a highly mobile hit-to-kill missile defense system. You can deploy it essentially anywhere in the world within 48 hours. All of the components can fit inside of a C-17 transport plane, so you can get it really anywhere where there's military presence. Hit-to-kill means there's no explosives on board our interceptors. All of the destruction portion is done with pure kinetic energy, which I think is really cool because it really is like shooting a bullet with another bullet while it's coming at you. It also reduces hazards to the operators because, again, there are no explosives, and it also reduces the risk of detonating incoming warheads. So it's deployed worldwide, primarily used by the U.S., but there are some other countries that have purchased and deployed THAAD. And it's right now they're working on bringing THAAD into the larger ballistic missile defense system, as Sean might be able to tell you more about. But really coordinating with other missile defense elements like Sean's GBI, or you may have heard of Patriot missile defense, or any number of other things. So I say I'm a systems engineer, but we have a running joke among systems engineers. We're not actually systems engineers. It's more accurate to say we're PowerPoint engineers. We do a lot of PowerPoint work. So my big group is called the Weapons System Engineering Integration and Test. Within that, I'm part of the Weapons System Engineering Group, Design and Analysis. And we're responsible for the entire systems engineering lifecycle, basically from the initial architecture design all the way up through CDR, or critical design reviews. My job right now, we are developing the system architecture and ConOps for the new THAAD system build. And as part of that, we're doing lots and lots of presentations to internal and external customers, like internal engineering review boards, or external customers like the Missile Defense Agency. We actually have another review tomorrow at 8 a.m., which you know how much we all love 8 a.m.s. But you get lots of PowerPoint slides, so very familiar with PowerPoint. We're also responsible with coordinating with all of the different components of the THAAD system to make sure we're all working towards like a unified vision and everybody signs off on all of our design decisions and requirements. So for example, our radar is built by a completely different company, Raytheon, and their radar team is located up in the Boston area. We do a lot of work with our Patriot team, which is Lockheed Missiles and Fire Control, and they're located in Dallas. and then the ground system team is located in Huntsville. So we're pretty well spread out. So coordinating between all the different sites could be a full-time job in and of itself. But we make it work. Then on the next slide, some additional responsibilities my group has. So after we have our initial design finalized, so essentially right after your ConOps is done, we begin the process of running really tens of thousands of system simulations to validate our design. And we're not always right the first time. You know, usually nobody is except for Sean, because he has all the answers at MITRE. So problem identification and analysis is a critical skill. So when something doesn't work right, you have to, open up your sims, look at all of the data, how are all of your components reacting to different stimuli, and what can you do to make the design better. Some other roles our group has, we have to transfer data between all of our different sites because we're not all in the same network. So a lot of logistics work. And we also do a lot of trajectory generation because each one of those thousands of simulations we run requires many, many different trajectories to be generated. We've got a pretty wide range of things in the group does. Some other groups that just I work with on a day-to-day basis, like the MDS Studies group, they do like advanced capabilities analysis, our models and sim team, the requirements team, we're supporting them actually right now because they're gearing up for their requirements review with the customers. System performance flight test actually just had a successful flight test, I think it was last week, with actually going back to that coordination with other elements. They used a THAAD radar to launch a Patriot interceptor and do an intercept at a range beyond which the old Patriot radar could see. So that was pretty cool for all of us. The system integration team does a lot of hardware in the loop testing. So they've actually got a lab where they have a full-up tactical system that they have all wired together to validate our computer simulations with real-life tactical systems. And then the system interface team, which does a lot of message traffic control between the different components because the radar has to talk to the ground system, which has to talk to the interceptor, and you got to keep everything straight. And then to wrap it up, I linked a fun little flight test video from the flight test that occurred last summer, actually. Jamie stopped sharing your screen. There we go.
She hates
so this
Got it.
So this was actually last summer, right after I left my internship, and it was the first test of. You hit play.
How do I share my sound? Does anyone know?
You actually, I think I went through this with someone in Team at work, and they couldn't figure out a way that it went reliably.
There's really not a ton of sound, but.
Okay, well, I will just play the video then.
Yeah, the only part that has sound is the actual interceptor launch, which if you want to hear it, you can find this video.
Okay.
So this was our first operational test of one of the new capabilities last summer. This is actually a remote launcher, so you can stick just the launcher vehicle pretty far downrange of the rest of the ground systems. So for one of these flight tests, the Air Force drops essentially the top half of a missile out of a cargo plane somewhere, and then it'll ignite and fly like a real ballistic missile you would expect to see deployed in the field. Yeah, this test was out in the Marshall Islands, right out at the Pacific Missile Range. This would be where the cool thing is. And you saw a picture of Zach. Yeah, please show. You saw a picture of Zach earlier standing next to one of these things, so you can kind of get a sense of how big these vehicles are and how big the actual interceptor missiles are inside of that big truck. I think the next sequence of videos is the actual intercept. So, like I said, it's a hit to kill missile. So we are actually hitting the missile, and there's no explosives on board. We're just, all of the explosions you see are generated with pure kinetic energy impacting that target missile. This one's the last one. So this is the target. And you can see the interceptor coming from the side and destroy it. Very successful flight test. And that was it.
Wow,
Thank
very
you.
cool. I will also send, when I send out the slides, the link to that video will be in there if anyone is interested in watching it with sound.
Thanks, Jim.
Uh-huh. All right, next is Claire. Claire, would you like me to show your slides or would you like to pull them up?
You can show them.
Alrighty. Let me find where I put them. Oh, what the heck? Sorry. All right, got it. All right, go ahead.
All right. Well, I'm Claire. I graduated in May 2020. You can go to the next slide. So like I said, I graduated in May with a mechanical engineering degree. And in July, I moved out to Denver and started working at Lockheed Space Headquarters in Littleton, which is like 30 minutes south of Denver. I work as a thermal engineer in deep space exploration, which is part of the commercial civil space division of the space business unit. A perk of being part of commercial civil space is that I don't have to get a security clearance, so I can talk about my job with my friends and family and all of you guys. So
Very
as
jealous.
as a thermal engineer, my job is to set temperature requirements for spacecraft components, design thermal control systems, perform analysis on our spacecraft, and perform testing as well, with our end goal of making sure that all the components on the spacecraft remain within their range of temperature limits throughout the entirety of our missions. Right now, I have the privilege of working on 2 projects at 2 very different points in the design process. So I'm already getting to experience all the work that goes in from taking the idea of a spacecraft and really bringing it to life and taking it to launch. My first project is Lucy, and you can see a graphic of it on the left. It's currently in ATLO, which stands for Assembly, Test, and Operations. It will be launching in October of 2021, and we'll fly out to Jupiter and study the Trojan asteroids. My second project is Dragonfly, which you can see on the right, the little helicopter. It's in the early design stages of the design process because it launches in 2027, and it'll travel out to Saturn and land on Saturn's largest moon, Titan, to do analysis. Next slide. So my days look like a lot of work in desktop. We use that software to model our spacecraft and do analysis on how hot and cold the temperatures of our components get throughout different stages in our missions. Regularly, I meet with our systems team and other subsystems like telecom, propulsion, to discuss our analysis, and if there's any design changes that we have found that may be necessary if our analysis shows that one or more components reach unacceptable temperatures. My favorite part of my job is being able to go downstairs into our high bay and seeing the progress my teams have made on the Lucy build and any other testing that isn't thermal testing. So you can see the picture here on the right is actually taken downstairs in my building, and they're putting a propellant tank into part of the Lucy site. And lastly, I spend any other time training to be a mission ops team member, because once Lucy launches in October, I will work on mission ops for her. And that's it.
Awesome. Thanks so much, Claire. All right, now we can open it up. Does anyone have any questions? And they can be for, they can be for anyone or like everyone, if you want everyone to answer.
I've got a question.
All right.
Sean, I got a
Yes.
MITRE question. How does MITRE gather the information that they need about what other nations may be using as their means of missile programs? Do they get it from intelligence agencies? Do they do that work themselves, or is that part of the company and your job?
So MITRE has a specific group that actually works to do that threat analysis. I don't do that much work with them. I talked to my boss a little bit about it actually, because I'm interested in that side of it as well. And he said there's definitely plenty of room to research a lot of that stuff and learn the fundamentals behind how to get started doing it, as well as providing actual input at MITRE. So we do that at MITRE, yes, but I don't necessarily know.
Thank you.
All right, well, we have a question that was submitted beforehand, and this is a question for everyone to answer. So the first part is, what are some things that you wish you did or did not do as a freshman in terms of joining organizations, applying for internships, and getting experience?
I don't know about everyone else's like experience with internships, but I know like a lot of people, it's not easy to get an internship, especially just because there's so many people applying. You could apply to hundreds and not get an interview, or even like you could get like 5 rejections and just like ghost on everything else. And so just like there's no reason to be discouraged if you don't get an internship. Like I didn't have any internships throughout school. And like I know Zach, I don't think Zach did. And so like you could still get a job. It's not like end of the world if you don't.
That being said, talk to alumni. You know, we
Yes,
are here to help
agreed.
you as well.
And then I know, I don't know how it is for other companies, but I know like Lockheed, you can't refer people to entry-level jobs, but you can, like if an internship opens up on your team, you could like have someone submit it. But like you could talk to your boss and be like, hey, like this person I know that applied for this job. Go ahead, Logan, if you're.
I can say something as well. Or Logan, you want to go?
Yeah, Jacob, that's definitely not true. You can definitely apply or refer people to entry-level positions.
I was told that was not a like, and it doesn't come up on the referral website.
That does. I referred Spencer Kennedy to like 8 of them. So
Is that just an ARA or a rotary missions thing?
Yes, Claire also recommended me for a couple.
Oh, maybe space allows it, but like
Yeah, maybe
rotary
it's just
doesn't.
space. I know ARA and RMS definitely don't.
Who wants to work with helicopters, to be fair?
So I referred Spencer to several space jobs and then several RMS jobs that they had posted to like the global page. So
One of the things that I'll say is definitely a bigger change from school to work. So because I have to look at all these people's designs, I have to have the right access, which means that I just got an appointment to get a special card that lets me review all of this data. And it's October. So from May until October, it's been nothing but learning new things, creating new programs, exploring tools that I want to learn better. But it doesn't necessarily mean that I've been doing analysis work for the GVI program or for that or for anything else. One of the things that's helped me the most was just the amount that I wanted to learn in school. That carried over. The difference is in classes and homework and things like that, you get a step-by-step list. Solve this problem, do this assignment. This is the next thing that you have to do. If you ever get into a point where you're waiting on badges, or you don't have a lot of stuff coming through, it can be a really weird adjustment to go from like 100 to 0, and you can feel like you're stagnating a little bit. That is something that I have noticed.
I don't have anything that I wish I did or didn't do as a freshman, but there is one thing that I was really glad I did, because like they said, it is hard to get an internship your freshman year. I went to professors on campus and asked to do research with them, and working with a professor one-on-one helps you to have someone to speak for you. So whenever you do have a job and they're looking for recommendations or anything like that, they personally know you. I got one of my internships because the professor I worked under did speak so highly of me. And they let me know once I got that job that he really pushed me to the front of the interviewees. So that is something I would suggest doing if you're not really getting responses from companies, is to go find a professor on campus and see if they have openings to do research.
So I guess I didn't really answer the question when I started talking. I was more focused on telling Jacob how wrong he was, because that's one of my favorite pastimes. But, going along with the theme, you're never too young to do, oh my God, Liam, that is a beard and a half.
I was about to say the same thing. That's disgusting.
No, but you're never too young or too inexperienced to try to apply to, internships. Like I got an internship as a sophomore. Where, like you said, like asking professors about research opportunities, like the opportunities are out there. They're few and far between, but it just means you have to be all the more dedicated to find them.
All right, thanks, guys. I think we have a question from Ian next.
Hey, I had a question for, oh darn, I forgot your name. Find you in the chat, and then I'll actually can direct it to you personally. No, I can't. Claire, yes.
Yes.
You muted yourself, Ian.
Darn it, hit the wrong button. Sorry. Okay.
Ian, come back.
Yeah, I'm here. Okay. Claire, how did you get involved in the deep space side of Lockheed Martin? Because I'm very interested in deep space, more of the propulsion side, but just right now, deep space in general. Like, how did that process go for you getting into the deep space side of thing, the side of such a large company?
Yeah, when I was talking about the research that I did kind of focused on like the fluids area. And so summer after my junior year, I just applied to an internship with NASA and said, what the heck, like the worst that could happen is they say no. And I got the internship because my professor spoke so highly of me and spoke of my work ethic. And so I went, everybody said they kind of got hired on that Lockheed Martin day in last September. And so I went up, just networked with people, told them about my experience working with propulsion at NASA, and they found me a spot in deep exploration.
And sorry if you weren't finished, but something to kind of like add on to that too is if you get a position somewhere and it's not like the exact job that you want or the location that you want, like take it, because it's a lot easier. And I know especially with a place like Lockheed that has a lot of different lines of business and locations, like I mean, I knew I wanted to move up to Northeast and I switched jobs in like 2 months. Like once my boss was like, oh, this is where you want to go, it was like literally a month later he was like, oh, here's an opportunity. And I think like I know a lot of other people who have also like looked at different opportunities and moved within Lockheed, and so also something else to keep in mind.
So you're saying like it's easier to network from the inside than it is on the outside.
100%.
Yes, absolutely.
Yeah, like one example is my boss has moved around to 10 different jobs within Lockheed in her 15-year career here. So they don't hold you back from moving you to like a job that you're more suited for, or they don't like there were a couple opportunities that opened up, and I applied to one of them that and my boss said, yeah, I know, if it's what you want to do, then go for it. So Lockheed, at least I know, is very open to allowing you to move around.
Also, you don't have to stay at the same company if you don't like it. Most of the people I work with came from Raytheon or Northrop or Aerojet or even Lockheed Martin, just because they wanted something completely different.
Nobody leaves Lockheed. It's the best company in the world, Sean.
They don't let you leave, Sean.
Well, thank you guys.
All right, I have another question submitted ahead of time. So what are your tips for applying for jobs when you're about to graduate? Besides go to the career fair, because we hit that one.
Do it early, do it often.
Apply to any jobs that look interesting to you. There's never too many applications you can put in, and definitely make sure your resume is tailored to the job that you're applying for.
Don't be afraid to go outside your comfort zone either. I applied. I thought I was going to be working for Aerojet, and I'm at MITRE and actually much happier.
I'll add one more thought. Like if you do get an interview from really anywhere, just don't be afraid to be yourself. Don't put too much stress on yourself, because they're hiring you. The reason that you're getting an interview in the first place is they think you will be a good fit for their team. So they already kind of like you. So just make them like you a little bit more.
And I know it's kind of hard for me when I was applying to message alumni and message especially people that were that I didn't really know on our team from in Aries, but it's a lot at least for me, I know, and the people I've talked to, no one is it's not hard to help somebody. It's a very easy thing, and people want to help, especially people from their teams get positions. And so reaching out and even just saying hey, I was just looking at this position, and it's a lot better if you see a position that you want and hey, I was looking at this, do you know if there's anything I could do? Or a lot of companies have referral application links that kind of puts you at more preferred status than if not. And so even just little things like that is nothing for the person, the employee, gives you a much better chance than just cold applying.
Don't get discouraged if nothing is coming up either. After the Lockheed Martin days, it was kind of weird. I felt a little sorry for myself at first, and then I stopped that pretty quickly because a bunch of my friends had jobs or internships or places that they were going. I didn't get a job until it was about April, so it was much later, and that was kind of a weird thought at first. But if you just kind of keep putting one foot in front of the other, keep applying to different jobs, and I don't know, keep looking, stuff will come up, and you'll eventually find one that you really enjoy.
Don't be afraid to send your resume to any alum either. A lot of times, the resume help in the Ferg Center isn't always tailored to what the companies are looking for. And so if you have people out in the industry look at it, they can give you some more accurate feedback than what you would otherwise receive.
All right, those are all awesome answers. So we have about 5 minutes left. Does anyone have any last questions that they'd like to ask?
Don't be shy.
All right, I can ask a question. Oh, perfect question. Okay. Oh, this is a great one. Are there any skills you didn't learn in ARA or in class that you would recommend learning? Logan says yes.
Yes. Definitely.
What are they?
Python is always very helpful. Other data analysis tools. You do some MATLAB in some of your classes, but I think I only did MATLAB in one class. But any of those scripting languages, because you don't have to, we're not going to expect you really to, be a master coder, but it's really easy if you can hop right in and just like start doing stuff, like write a little thing to read some data out of files and put it on a graph. That's all. That's all really helpful. That, and if you've never been exposed to Linux before, a lot of places use Linux. Red Hat Linux is very popular, so recommend getting some Linux exposure if at all possible.
For it's kind of tough because I mean there's a million different programs out there, and like every company kind of uses different ones. Like we were talking about it right before. Like Lockheed uses like CATIA as its 3D modeling program, and so things like Linux and Python are like very generally useful things. And something that I came across that has helped me is just like general like automation using VBS or Python, like macros to do a repeatable task. I know it's something that my boss was very happy. Like when I first got here, I was like, oh, like you could use this. Like my supervisor, I was like, oh, you could do something like this for that, and he was like, oh, this is really good, and like sent it out to the team, and it's something that you could really use to help, I guess, help yourself and your team.
As far as skills go, I'd say just try to keep up your appetite to learn. If you're not a big fan of learning, maybe it's just a particular topic in school, but the more that you can learn on a job, the more that you're going to be able to be used and passed around to other teams, and you might find a completely new environment that you never thought you'd be working in. That's something I've kind of seen in a lot of my coworkers as they bounced around from place to place. Just the ability to pick up new programs or learn different softwares, or even things like Logan was saying with OS systems and stuff like that.
All right, that's perfect. Thanks, guys. And then we had one last question submitted, which is, I see that no one on here from Lockheed has a beard. Are they specifically anti-beard, or are they just intimidated by larger beards? And that was anonymous.
I'm waiting for No Shave November.
I am curious, but I did not submit.
They support beards in our location, actually. They just had a meeting talking about how facial hair was okay. Facial hair, tattoos, and piercings, and different colored hair. They had a meeting supporting that like last week for our location.